Hello friends, welcome back to the channel. In the previous video, I have discussed about the inductor, and in today's video, I will discuss about another electrical circuit element, that is capacitor. And just like inductor, it is also a storage device. Capacitor is an electrical device used for storing electric charge, and it consists of two parallel conducting plates in this way, and these parallel plates are separated by an insulating layer in this way. This insulating layer, this is known as dielectric, and these two are the parallel plates. This is plate number 1 and this is plate number 2. Now when a capacitor is connected in circuit across a voltage source, means if we are applying voltage across this capacitor, this voltage forces electrons to the surface of one plate. Means the concentration of electrons will be more on one plate and pulls electrons off the surface of the other plate. Means that polarization will be there. At one plate, negative charge will be collected, and another plate, positive charge will be collected. So this polarization will result in potential difference between plates. This potential difference is due to applied voltage. Now this capacitance is proportional to the charge which can be stored and inversely proportional to the applied voltage, and this capacitance is measured in farads. Inductance is measured in Henry and this capacitance is measured in farad. You can add units that milli, micro or nano. So if its value in milli, then it will be millifarad or microfarad or nanofarad. Now the parameters which affects the value of the capacitance, the first is area of plate, then second is distance between plates, and third is dielectric constant of material between the plates. So C, it can be written as C is equal to epsilon A upon D. If dielectric constant is more, then capacitance will be more. If area of plates is high, then this capacitance will be high, and if distance between two plates is more, then this capacitance will be low. So C is directly proportional to the dielectric constant, area, and inversely proportional to the distance between the plates. Now similar to inductive reactance, capacitance capacitive reactance is impedance offered by the capacitor. Inductance opposes the rate of change of current, and the capacitance opposes the rate of change of voltage. So the opposition offered by the capacitance to the rate of change of voltage, that is known as capacitive reactance, and it depends on frequency and value of capacitance. It is written as Xc is equal to 1 upon 2 pi Fc measured in ohm. So this is 1 upon 2 pi Fc ohm. Note that capacitance is measured in farad, but capacitive reactance is measured in ohm. Then if capacitors are connected in series, so it is opposite to the resistance and inductance. If C1, C2, C3 are connected in series, then the equivalent capacitance will be 1 upon C1 plus 1 upon C2 plus 1 upon C3, or if n capacitors are connected, then similarly, at denominator 1 upon C3 plus dot 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 plus 1 upon Cn if n capacitors are connected in series, and if n capacitors are connected in parallel, then this will be C N. So with this video, the discussion about the basic circuit elements, resistance, inductance, and capacitance is complete. In the upcoming video, I will discuss about the basic problems related to these circuit elements, or simplified circuits. How to simplify those resistive circuit. So stay connected with the channel for watching the solution of those problems. You can view the other videos only by subscribing. If you will subscribe, then you will receive immediate notification. You can share your comments or your views in comment box. You can also share this video or the similar video with your friends. See you in the next video. Bye bye. Thanks for watching.